Here we have the function y equals x squared, and what I've drawn is a vertical line that is x equals -1. And when I apply the vertical line test, any vertical line would touch a true function in only one point. So if I have an input of -1, then the output for the y would be +1. And anywhere I drop this vertical line, it will only touch the y equals x squared function in one place. When we're mapping functions, what we're talking about is that for any input of the independent variable, which is x, I should only have one output, which is going to be a y. So if my x input on the y equals x squared function is applied, then -2 maps over to be +4, because -2 squared is 4. 0 squared gives me 0, 1 squared gives me 1, and 2 squared again gives me 4. Now you'll notice that we have the 4 written in two different places here. What I could have done was I could have said that 2's output is the 4 over here and not have this 4 here. Now, while it's true that any independent input of x should only have one output, we can have a y that is the result of more than one type of input. So here I have a vertical line drawn for x equals 0, and the x equals 0 line, this vertical line, then touches the circle in 2 points. When my input value is 0, I have both a +2 and a -2 for the output. Mapping this, I see that my input value for x is 0, then what my resulting output values are both 2 and -2, so this fails the vertical line test, and this is not a function. One thing to note, if I look at the circle here, that my vertical line, instead of being x equals 0, if I was to move that between -2, +2, that there exists two values where the vertical line test does give a single output value. So at -2, x equals -2, y is 0, and at x is +2, y is 0. Now for a function, we would be allowed to have two separate input values that have the same output, and this is an example of that. But at no point anywhere on the curve should there be more. So with the vertical line, if I'm at this location, you'll see that the vertical line test touches the curve in two spots, therefore a circle is not a function. Let's look at a few examples to see if you understand when the mapping represents a function and when it represents a relation. So here, what we have is each input x, our independent variable, results in only a single output in y. So 5 maps to 0, 4 to 9, and 7 to 2. So this is a function because each input value has one and only one output value. In this example, we once again have a function because each input of x results in only one output of y. Even though y's value of 2 is the result of two separate inputs, each of the inputs only has one output. So this does represent a function, and it doesn't violate that the inputs don't have more than one output. In this example, we do not have a function because we see that this single input value of x does have more than one output value of y.